In our previous video, we dealt on addition law, we dealt on subtraction law, and now we'll be taking a look at the power law of logarithm. So let's take a quick recap again on the relationship between indices and logarithms. So we have x to the power n related to y, and this will result into log of y to base x, which will be equal to n. So in respect, we're saying that the base raised to the power of the index is equal to the number, and that means the log of the number to base is equal to the index. Now, the power law simply states that log of b, or let me say log of p raised to the power of n to base b is equal to n log of b p raised to base b. So what it's implying basically is that this n comes to the back and becomes a scalar multiplier. So with that done now, let's proceed on and show how it is being derived. So from inception, we have been saying that p is equals to b raised to the power x, and when we convert this to logarithm form, we have this to give us log of p to base b is equal to x. Therefore, if you say p raised to the power of n, now this brings us back to the power law of indices, where we say x raised to the power a raised to the power of b. Now the power a and b will get multiplied, so this will give us x raised to the power of ab. This is just indices. Therefore, we are saying that b raised to the power of x all raised to the power of n, and this will result into b raised to the power of nx, n be the multiplier. Now, if p raised to the power of n is equals to b raised to the power of nx, therefore if we convert this back to our logarithm form, we realize that log of p raised to the power of n to base n is equal to nx. Now we have been able to establish the right hand side. It's similar to this. Okay, now what is x? Our x in this case is what? Log of p to base b. So this is bn log of p to base b. So we can see that this relation here is similar to this relation here. So yes, it has been proved. Therefore, we can now come to the final conclusion that when we have log of p raised to the power of n to base b, the result will be n log of p to base b. Now let's take a quick questions on that. Let's begin with a simple one. It was given to express log 4 to base 3. Now 4 is equals to 2 raised to the power 2. Okay, so therefore we are saying that this will result into log 3 log 2 raised to the power 2 to base 3. Now if we apply the power law of logarithm, we realize that our 2 here is equivalent to n. Okay, and 2 here, this 2 here is the same thing as the p, and 3 is the same thing as the b. So if you apply this now, our 2 becomes a scalar multiplier, and this will result into 2 log 2 to base 3. All right, let's take more examples to establish the understanding. So let's say log of 2 of 9 to base 2. Now 9 is equals to 3 raised to the power of 2. So this will give us 9 3 raised to the power of 2 to base 2. Now the 2 becomes a scalar multiplier, and this becomes 2 log 3 to base 2. Let's take another example where I have log 8. Log 8. Now this means that it is of base 10, but we want to get into the habit of not writing it. So log 8 means log 8 to base 10. So log 8 in this case is 2 raised to the power of 3. So this is 2 raised to the power of 3. Now 3 becomes a scalar multiplier, moves to the back and becomes a multiplier. So it goes 3 to log 2. 3 multiplied by log 2. Let's look at a more complex one. We have log 64. Now 64 can be written as 2 raised to the power of 6. 64 can also be written as 8 raised to the power of 2. So log 64 now can be written as log 2 raised to the power of 6, and this will result into 6 log 2 because the 6 comes to the back. Log 64 can also be written as log, okay, let's make that a little bit clean, can also be written as log 8 raised to the power of 2, and this results into 2 log 8. 2 log 8. Now if you go a step further in simplifying this now, so if I have 2 log 8, that means log 64 is still equals to 2 log 8. I can still simplify log 8. Now in this expression, our log 8 is equal to 3 log 2. Okay, so I can just say 2 into 3 log 2. So this will multiply each other and that will give us 6 log 2. So we can see a final expression for log 64 here. Log 64 is 6 log 2. Log 64 is 6 log 2. Alright, so what if we don't have an expression for log 8 at the instant? So let's go over it again. Log 64 is equal to log 8 squared, and this will give us log 2 log 8. Alright, now 8 in itself is 2 raised to the power of 3, so this will give us log 8. Now we will rewrite 8 as 2 raised to the power of 3. In the same vein that we have been having 2 comes to the back, 6 comes to the back, 3 will also come to the back, and it will give us 3 multiplied by 2 log 2, and this will be 6 log 2. Okay, so with that established, let's take another example in this format. So in this format we have log 81 rather to base 3. Now 81 is equal to 9 raised to the power 2, so we can start with that, and 81 can also be written as 3 raised to the power 4. So let's start with 9 raised to the power 2 to establish understanding. So this will be log 9 raised to the power of 2 to base 3, and if we apply our power law here, this will become log 9, 2 log 9 to base 3. Now 9 is the same thing as 2 log 3 as 3 raised to the power 2, because 9 is 3 raised to the power of 2. Therefore this 2 again will come to the back as it was before, so it will become 2 multiplied by 2 log 3 to base 3. Now this will give us 4 log 3 to base 3. So in the same vein, if we will have gone through 81 is equals to log 1 is equals to 3 raised to the power 4, so we just say log 81 to base 3 is log 3 raised to the power 4 to base 3, and this will give us log 3 to base 3. Okay, let's take a final example on this. So we have log 0.001. Okay, yes, we don't have a base, so it will be taken as base 10. Base 10. So this will give us 0.001 is equal to 10 raised to the power of minus 3. So this will give us log 10 raised to the power of minus 3. So when we apply the power law to this, we will have it to give us minus 3 log 10.